Okay, everybody, today we are going to learn about what's going on in the sediment in the soil. Okay, well first, I want to introduce you to a couple basic terms. The first is porosity. Now, porosity refers to how much empty space exists in the soil or in the particles of sediment that make up the ground beneath us. How much empty space exists down there. So, I'll make a little note here that porosity is the total percentage of empty space in the soil. If you take a look at the samples over here, we have round particles representing particles of rock in the ground beneath us. On average, the amount of total empty space in a container like this would be something around 38, 39, 40% empty space. That's typical when you have round particles of all the same exact size. That's called being well sorted. About 38, 39, 40%. Now, the next is permeability. Permeability, you might remember learning about last year when you learned about the cell. How the cell was permeable to oxygen and permeable to water in certain situations, and how certain substances could not get in. It was impermeable to other substances. This refers to the ability to let something in. Permeability is the ability to let something pass through or enter. So let's make a little note of this. That permeability is the ability of water to pass into or through something. You could say the window screen is permeable to air, permeable to water, but it's not permeable to flying insects. You could say the window closed, the glass, is permeable to light. It lets light pass through, but it's impermeable to water. It doesn't let water pass through. So that would be the window screen being impermeable and permeable at the same time. Okay? Okay. Now, the next interesting concept here is called capillarity. Now, capillarity is the upward movement of water through the soil. Upward movement. Now, if you've ever seen a paper towel dip into a spill, you'll sometimes notice that the water creeps upward in the paper towel. If you've ever done chromatography and put a piece of chromatography paper in a beaker and watched the water climb up through the chromatography paper, or if you've seen a towel touching water and water climb up into that towel, you've seen capillarity. Capillarity is the upward movement of water through tight spaces. So that is what's called capillarity. Okay, everyone, now we're going to take a look at what's going on down there beneath our feet, what the porosity and permeability has to do with what's going on beneath our feet. So let's take a look at what happens when we have water and all the material beneath our feet, the soil, the particles, the regolith, as it's sometimes called by scientists, the sediment beneath our feet. Take a look. First, there's 4 or 5 things that can happen to rainwater that falls upon the land. The rainwater can evaporate and go back up again. It can get soaked up by trees. That's called transpiration. It can flow over the land, flow downhill, wind up in some river. That's called runoff. Or it can seep into the soil, which is known as infiltration. Now, if you think about what you learned a few minutes ago, it will only be able to infiltrate if the soil is permeable. The soil has to be permeable to the water in order to let the water infiltrate. So infiltration is the seeping of the water into the ground. I will just sort of demonstrate. Here we have the infiltration of the water. Okay? Now, if you dig down beneath your feet into the earth, at some point, if you dig down far enough, you are going to encounter a layer of solid rock that will allow you to dig no further. That solid rock is referred to as being impermeable. And the reason why the solid rock is impermeable is because it will not generally, usually, allow water to pass through. Now, the name of the rock layer beneath your feet that you will find eventually if you dig is known as the bedrock. The bedrock is the layer. And bedrock is usually impermeable, right? Which means water cannot enter or penetrate this solid rock. Now, what's going to happen? The water is going to continue to infiltrate through the soil until it reaches the layer it cannot infiltrate, which is the bedrock. Then the water is going to back up. The water is now going to fill the spaces between the particles. So from the bottom up, the spaces between the particles, and what did we call those spaces before? They were called pore spaces. The pore spaces are going to become filled with water. Now, let's imagine that in this whole area right here, all the pore spaces between the rock particles are filled entirely with water. We're going to refer to this layer here as the zone of saturation. Now, we've learned from meteorology, saturation means being filled up with water. In this case, the particles, the space between the particles, is filled up with water, hence the word saturation. The zone above, the zone that's allowing the water to pass through, does not have particle spaces filled with water. Those particle spaces are still filled with air. So this is known as the zone of aeration. Now let's think about this a little further. Let's imagine that it's August and it hasn't been raining in weeks. It's a drought and it's hot. This zone of saturation is going to become more narrow as water continues to leave and evaporate. The zone of saturation will go down. Now let's imagine that we've had many, many days of rain and water has continued to infiltrate into the dirt beneath our feet, into the particles. What will happen then is the zone of saturation will continue to acquire more and more water and it'll become thicker. This top of the zone of saturation, this interface between the zone of saturation and the zone of aeration, is known as the water table. And that's a very common term you all have to know, not just for earth science, but for being a citizen and living in this world. Now, your water table will rise when water is plentiful, and your water table will fall in times when water is scarce, as the zone of saturation becomes more narrow and thicker. Now let's take this a step further. Let's think about this. What if the water table actually reaches the surface? If the water table actually reaches the surface, will any water be able to continue to enter? Well, the answer is no. Any water that tries to enter will be forced to just simply flow across the land. We have what's known as a flood, an example of runoff. So again, impermeable bedrock, zone of saturation in which the water is filling the particle spaces between the particles. The water table, the boundary separating that from the zone of aeration, where all the spaces between the particles of rock are filled with air. Okay, everybody, we're back to our layers of earth beneath us. Once again, our zone of saturation, where the water particles fill up where water fills up all the space between the particles of rock. The zone of aeration, where air is filling the space between the particles of rock, and the water table, which is the boundary between those two. The surface, the top of the zone of saturation. Now, what's interesting is, we told you before that the upward movement of water is known as capillarity. Now, where does that occur? Well, the upward movement of water is going to occur from the water table. Water is going to creep upward through those tiny, tiny particles from the zone of saturation, from the water table upward. Now let's think about this. Well, capillarity is defined as the upward movement of water through the tiny spaces. The tinier the spaces, the higher the water will get to climb. The bigger the spaces, the less successful the water will be in climbing through these spaces. So if you have very, very small particles, such as clay-sized particles or maybe some silt, the capillarity will be greater. Water will climb higher. If you have maybe sand-sized particles or some bigger silt, capillarity might not be quite as great, water won't get quite as high. Pebbles, capillarity is almost essentially non-existent. Water is that big. Now, what makes the zone of capillarity particularly important is that that's actually the zone where plants' roots reach down and pull water from. Plants get their water from the zone of capillarity. That's where the root hairs soak up water from that particular zone. If plant roots were in the zone of saturation, they would simply just rot away. They can't be in water all the time. So here we have the zone of capillarity. Capillarity's got two L's. Okay, folks, we're not done yet. We have one last phase, and that's a closer look at the concepts that we just explained to you. Here I have a column full of small earth science beads. The earth science beads are used to represent tiny rock particles in the earth. You've learned that those particles are called sediment. Scientists sometimes refer to the loose rock beneath your feet as regolith. I'm hesitant to use the word soil because soil is very specific. Soil has a certain amount of decaying once living matter in it, so we don't want to really go there right now. So let's consider this to be just rock particles, fragments beneath us. Now, I've got some colored water. It's going to represent the rainwater. The rainwater is going to fall upon the land, and the water is going to do what? What is the word for penetrate these particles? The word is infiltrate. And why will the water infiltrate? The water will infiltrate because the particles collectively are very permeable. They're allowing the water to infiltrate. That's what permeability is all about. Now, the water will not be able to infiltrate past this point. We have this whole thing pinched off. Water will not be able to travel beyond this point. Therefore, the bottom of this is going to represent our layer of impermeable bedrock. So now let the rain begin. Okay, we have got our infiltration, permeability. Now let's take a look at what we've got. Let's have a second rainstorm, shall we? What the heck, let's have a third one. Many days of rain. Okay, let's take a look at what we've got. The water passed through, it infiltrated. You witnessed that yourself. All right, what name would you use to refer to Zone A? Zone A would be known as the zone of what? Zone of saturation. Zone B. Zone B. These particle spaces are not filled with water. Particle spaces here are filled with air. You would therefore refer to Zone B as the zone of aeration. And finally, interface C, which is the top of the zone of saturation, separating the zone of saturation from the zone of aeration. What would we call layer C, or interface C? It's actually a much better way I should say it. An interface is a boundary between two layers. Interface C is known as the what? Give you a second to think about that. It is called the water table. Now, what happens to the water table during times of excessive rainfall? Well, the water table rises. In this case, the water table has risen so much that it's actually reached the surface of the earth. And now we're going to have flooding and runoff. Okay.